Hi everyone, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with the lecture 2 of structure of atom, right? So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. So, guys, we know that we have done some basic things like discovery of electron, discovery of proton, we have already done, right? And now we are going to do Thomson, Rutherford, EM waves, photoelectric effect, black body radiation, Planck's theory, right? So these many things we are going to do in today's lecture, right? But before that, let me see in the chat box, right? On the display here, how many of you have done the homework, right? So Ramu has done the homework, Abhijit has done the homework, Rai has done the homework, then yes. So very good, very good, very good. Glad to see you. I am also glad to see you, right? So firstly tell me, chapter 1, are you also doing the revision of chapter 1? Because let me just show you here. I don't know if that is uploaded now or not. I'll have to see that. Yes. So if you see this here, right, in the description box here, some basic concepts of chemistry. This is the DPP of some basic concepts of chemistry. You'll click here. You will get to this particular PDF, right, where the solutions are provided to you. In total, you have 15 questions here. And I would love to see that you guys are actually doing the DPPs as well, right? So this is the, along with the homework, this is your DPP that you can solve. Firstly, try to solve it yourself, but after that, you can see the detailed answer as well over here. You can see the detailed answer as well over here. If you have any doubt in any of the question, then you can let me know also, right? It is in the description box only, right? Yes. Most welcome, right? Now, let's talk about today's lecture. Today, we are going to talk about, this was the homework, right? And let's firstly see what was the homework. The anode ray obtained from all the gases consists of positively charged particles called proton. This is true or false? Anode ray from all the gases consist of positively charged particle, but they are not protons. Only hydrogen forms H positive, which is a proton. Other gases form gaseous anions, right? Gaseous ions. Other gases form gaseous ions, which are multiple of proton. They are not proton, they are multiple of proton. Okay, that you should know. So this is a false statement. Let me see what you have written. True, true, you guys have written, but this is actually a false statement. Okay, so this is a false statement. You see, all gases consist of charged particle called proton. No, hydrogen is called a proton. Other are multiple of proton, right? Next is the term electron was coined by Faraday, Crook, Stoneley or Chadwick. This I have already told you. Let me see what you have written here. C, Stoneley. Second is Stoneley. That is C. C. Very good. Yes. So answer is going to be Stoneley. Right. So first statement was little contradictory. So I think now it will be clear to you that why we used false rather than true. Right. Now, starting with the models, firstly, we are firstly going to talk about Thomson model, then we are going to talk about Rutherford model. Now, when we know that there is electrons, there is proton, in Thomson and Rutherford model, till now, they have no idea that there is existence of neutrons. No idea was there, right? So, when we talk about Thomson model, right, they only knew about electron and proton, that electron exists and proton exists, right? Now it was said that Thomson, who discovered the electron, was the first to suggest a model of atomic structure. First is all atom contains electrons, that all the atoms that you have, they contain the electrons. That is suggested by Thomson, right? All the atoms that we are talking about, they are containing the electrons. then atom as a whole is neutral. That means electrons and protons are neutral with each other, right? The total positive charge and total negative charge must also be equal. So if I say I have 5 electron, I should have 5 proton in a neutral atom. If I say I have 10 electrons, I should have 10 protons in a neutral atom, right? So that means it is said that it is it is the electrically neutral atom. And how it is arranged? He said that it is arranged like you see watermelon, right? So how is watermelon? How many of you love watermelon? I love watermelon, right? So it's like the red part that we eat, these are protons, right? So he said that you have a full plain red part, that is your uniformly distributed positive charge, right? And when you talk about electrons, they are embedded in the red part, just like the black seeds are embedded in the watermelon, right? So that is your electrons and positively charged protons. So it is also compared to plum pudding model, right? You have plum pudding, or it also can be, for example, you have see anything you can compare it with, right? You have a juice, you add, let's say you are having mango shake, right? So you're having mango shake. The mango shake is actually your positively charged, uniformly positive charge. And the seeds, if you're adding nuts into it, you're adding seeds into it, those seeds and nuts are nothing but the garnishing that you do on the on the mango shake. That is nothing but that is your electrons that are embedded in it, right? So anything you can relate it to. So it is also called plum pudding model, it is watermelon model, and simple, it is the Thomson model given by Thomson. Now, after this, the drawback of Thomson model was that though the model was able to explain overall neutrality of the atom, it was able to explain the overall neutrality, that positive charge is equals to negative charge. But it could not satisfactorily explain the results of scattering experiment. It was not able to explain the results of scattering experiment, like there was Rutherford that will give the model after this. So scattering experiments were done by Rutherford, right? In those experiments, right, electrons, how can we take out electron from the atom, all these things, right? So one thing is that if electron is embedded into it, we can't, just like we cut the watermelon, we can't cut the atom and take out the electron from there, right? If positive and negative charge is same, then how can we take out electron from there? How this is actually possible? So that was the drawback of Thomson model. But good thing is nobody will ask you Thomson model, right? Nobody is going to ask you Thomson model. What they will ask you is Rutherford alpha scattering experiment. That is our second experiment that we are going to talk about. So what exactly, this one is very important for your exam, right? That is Rutherford scattering experiment, right? What he is doing here, right? Just like the drawback here, scattering experiments carried out by Rutherford, these were not explained by Thomson. So what were these Rutherford scattering experiment that he was doing? Let's understand that. See, Rutherford is like, he was not intentionally trying to prove Thomson wrong. He was doing his experimental scattering experiments, right? On doing the scattering experiment, first thing is Thomson was not able to explain the scattering experiment, right? Second thing is, after doing so many scattering experiments, his team, Rutherford's team, himself identified the structure of the atom. So it was not an intentional move, it was an accidental move, right? So let's see this. Rutherford alpha ray scattering experiment. For that, you need to tell me one thing. What exactly is this alpha ray? Alpha ray is what? You have helium atom. You take out 2 electrons from the helium atom. So helium atom, right? When you take out 2 electrons from helium atom, that becomes your alpha ray, right? Now, this helium atom is positively charged. That means alpha rays are positively charged. Now we are going to see what exactly he will do here. He conducted scattering experiment. Now see what he will do here. This is the diagram. From the diagram, I'm going to teach you what exactly will happen. For that, you need to have like full understanding of this. And one more thing, students, I'll also show you this with the help of one simulation, right? That is there on the Google itself. You can try it yourself as well, right? So that will really help you to understand things in more detail, right? So when you see Rutherford model of an atom, right? So here, three things were there. First is we are scattering the alpha rays. That means we need alpha rays for that, right? So here you have lead block, and this is the radioactive source, right? This radioactive source is the origin of the alpha rays that we are going to fall on the atom. These alpha rays are going to fall on the atom, right? So these alpha rays will fall on this particular sheet, right? And what kind of sheet we are using? We are using gold foil here. We are using gold foil here. And that is of very less thickness, right? Why less thickness? So that there are less atoms, so that alpha ray can actually pass through it, so that we can, because if there are more atoms, then to conclude something out of it will be difficult. So we need a metal that can be cut into very thin sheets. And that, my friends, what is that called? If you remember from metals, metal has a property of ductility and malleability. Do you remember that? Ductility, drawing the metals into thin wires, that is ductility. Drawing the metals into thin sheets, that is malleability, right? Do you remember that, right? So here, what we see is, wait a minute. Yes. So if you talk about this thing here, then these thin sheets are nothing but malleability. Now this malleability, okay, sorry. So this malleability is the reason that we are using gold foil, because gold is a metal which is very thin, right? Which can be drawn into thin sheets, so we can easily pass the alpha rays through that, right? So this is your gold foil. Now, what is this circle here? Can you tell me what is this circle? Okay, tell me what we used for cathode rays, anode rays, because we were not able to see the rays. So we used a fluorescent screen, right? Fluorescent screen is your zinc sulfide screen, right? Fluorescent screen is that screen. This is the screen. Whenever there is a particle, it will strike on it, it will start glowing, right? So the particles that we are not able to see, what we'll do, we'll apply some fluorescent screen so that we can, whenever that particle is striking on the screen, we can actually observe that there is some particle like that. Okay, so here what we have, this is all over, we have the fluorescent screen. Okay, now what you have, alpha particles, gold foil, and fluorescent screen. Now I'm going to tell you, wait a minute, can you just give me a second? We are going to see this here only. I'll just do one thing here, because just give me a minute. Okay, just give me a minute. I'll just show you what exactly I'm talking about. So this is actually the simulations that I was talking about. So you can visit this site and you can see for chemistry we want to see. So I'll browse for chemistry, right? This is for chemistry. I'll just browse here. What we will browse, students? We will browse, wait a minute. We'll browse Rutherford experiment. Okay? Rutherford scattering experiment, so that you can actually visualize what I'm teaching you, right? So this is the Rutherford scattering experiment. See, here you have plum pudding model as well. If I click on this, what you will see, in a plum pudding model, same alpha particle. If I assume that, see, this is a limitation of Thomson model. So if I assume that, if Rutherford assume that the structure of atom is actually what is given by Thomson, then you have alpha particle source, right? It is moving like this, it is going like this, but in reality these are not the results that we are getting, right? These are not the results that this is a symmetrical motion, right? Alpha rays particles are moving in a symmetrical, there is no observation for this thing. Can you see alpha ray when you stop, when you actually then again you float alpha rays through the atom, there is no differentiation you can see at this point and this point and this point and this point. So Thomson model is saying it is uniform, right? But in Rutherford experiment, you will see entirely different results. I'll show you what are the results that you will see, right? So what are the results that you will see for Rutherford model of an atom? Guys, this is the zoomed in version of gold foil that we are using. This is one atom, this is second atom, this is third atom, fourth atom, fifth atom. Like this, you have millions of atoms in the gold foil, right? So we are just using a section of that particular thing. Here, what we are going to do, source of alpha ray, that is your radioactive element that we are going to produce here, right? So once you have source of alpha ray here, what I'll do, can you see these pink balls that are there? These are nothing but these are your alpha rays particle that we are representing here, right? So these are your alpha rays particle. So now what I'll do here, I'll keep the energy less, okay? And I would love to see the traces so that I can also show you that how they are moving and what are the observations that are made by Rutherford model. So see, can you see this thing here? Some of the, like most of the rays are going like straight. This is straight. If I increase the energy here, let's say, I think when you increase the energy, it will be more visible to you, right? How they are moving. Can you see most of the rays are moving straight? Most of the rays are moving straight. If I increase the energy to the maximum, you will get a more idea about it, that in just 1 second, how many rays are moving straight. Most of the rays, can you see here, are moving straight, right? But ma'am, we can also see some alpha particles which are deflecting here. So some alpha particle you will see are deflecting, deflected. Some alpha particles are striking this yellow dot here. This yellow dot is nothing but the nucleus, right, inside the atom. So he's saying that this is some small part. Till now, Rutherford has not told you that there is some nucleus. Till now, he knows that there is some center part here on which striking the alpha particle that is getting deflected. And if it is striking by a very, like just on this yellow dot, it will bounce back. Bounce back, it will take you time to see which ray is bouncing back, because one ray out of 20,000 is bouncing back. So very, very rare is bouncing back. Till now, this one is bouncing back. Can you see? This one just bounced back. Most of it are going straight, are deflecting. Some of them are deflecting. And just one ray we have seen till now that is actually bouncing back. So that means, can I say that there are 3 categories that are happening here? Observation done by Rutherford. So that's how you will also get to understand the Thomson drawback. So Rutherford was saying that most of the rays are moving straight. Some of the rays are being deflected at some point, and very few, like 1 in 20,000 is bouncing back. But if you see this particular thing here, if you see the model of plum pudding model, then when you put this, there is no such thing. That means Thomson model is definitely wrong, right? So now we scientists got to know an idea that this particular model is the correct model, where again we will see the traces maximum. When you increase the proton here, what you will see, when you increase the neutrons here to the maximum, so what you see that as proton is increasing, the size of positive charge inside it is increasing, what we will see that deflections are increasing to a great extent. That means one observation to conclusion, one part we can draw here, that observation we have done. Wait a minute, where is my marker? Yes, observations we have done here. Now it's a time for concluding things. We are saying the observations are majority of the alpha rays are moving straight. Some of the alpha rays are deflecting. Very rare are bouncing back. These are the three observations that we have. Now, every observation is going to conclude something for you, right? So, first observation is that most of it are going straight. See, alpha particle is positive charge, right? So if most of it is going straight, that means most of the space inside the atom is empty. Can I say that? Yes, students. So if I say most of the particles passes through it without any deflection, can I say most of the space inside the atom is empty? This is the conclusion. Most space inside atom is empty. That's why alpha particles are not feeling any repulsion of any sort, right? So that's why they are moving straight. Some of the particles, it's like this is the bodyguard. You want to meet your favorite hero, heroine, actor, whatsoever, right? So this is the bodyguard that you have. This is positive charge, this is the bodyguard. So when you come very near to the bodyguard, they will bounce you back. Similarly, here what will happen? Now you're not very near to the bodyguard. The bodyguard can see you. This guy is coming near to our hero, right? So what he will do? He will say, go, right? So you will be deflected from your path, right? So now in chemistry, why this is happening? Because alpha particles are positively charged. Nucleus is also positively charged. See, at that point, I'm saying nucleus because this is the conclusion of Rutherford. But if you don't say nucleus, we can assume that if observation is that here it is getting deflected, that means some sort of repulsion is happening. Repulsion can only happen with a positive charge. Positive and positive will repel. Positive, negative will not repel. Right? So that's why this positive charge is definitely there. That means alpha particle should be getting deflected by a positive charge only. That means in the center of the atom, there is something which is positive, right? So this explains that some alpha particles deflected, there means on the center of atom, you have something which is positive, but very small, Now third is, very few alpha particles, like 1 out of 20,000, just got bounced back. Bounce back means they will strike here, just bounce back as it is. Why? Because this is positive, this is alpha particle, there will be head-on collision kind of thing, right? So positive, more near, more repulsion. That's why bounce back will be there. And what we observed that because some of them are deflecting and very few are bouncing back, that means this particular positive charge here is very small. But that small area is very dense. That's why if you attack on that small area, it will bounce back, right? So it is very small, but it is very dense. Very small, right? But highly dense. And if someone asks you, Rutherford gave discovery of which thing? He talked about nucleus. Okay? Yes, everybody? Hanji, yes, ma'am. Okay, syllabus completed, ma'am. Yes. Don't worry, Zoro, that's our responsibility, right? You just leave it on us, right? That will be completed, right? You just focus on understanding the things, right? So here it is, 1, 2, 3, most space is empty, center of the atom positive charge, very small. Is that clear to everybody or not, right? Let me know in the chat box if these 3 points are clear to your head or not. Okay, students, got it? Right, everybody? So that is our very important thing, that when we talk about this thing, the small dense part, it's like that particular thing he named as nucleus, right? So observation, this I have already told you, conclusion is most of the space in the atom is empty. observation is a small fraction of alpha particles were deflected. This states that positive charge has to be concentrated in a very small volume, repelled and deflected by positively charged alpha particles. Then observation is small fraction is this, then that is also the same conclusion that the positive charge is very dense in a very small volume and it is positively charged. Right? Now, when we saw, we Rutherford said that this small positive hole that you have inside the atom, that is actually called the nucleus of the atom, right? That is in the center of the atom. He said that volume occupied by the nucleus is very small as compared to volume occupied by the atom. You can compare it with the cricket stadium. This is a cricket stadium and this is your Virat Kohli or MS Dhoni, whomsoever you love, right? So this is your Virat Kohli, MS Dhoni. I don't know that much about cricket. Okay? So this is the cricket stadium and this is your cricket ball, right? And here cricket ball is so small in front of the cricket stadium, right? So same is with atom, right? The nucleus is very small as compared to the atom that you have, right? So you can say that here it is very, 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 very small. It is so small. If you need to tell the dimensions, radius of the atom is about 10 raised to power minus 10 meter, while that of nucleus will be 10 raised to power minus 15 meter. We say that if the radius of the atom is 10 raised to power minus 10, then the radius of the nucleus will be 10 raised to power minus 15. That means it is 10 raised to power 5 times smaller than the atom. Okay? We can also write down the, this is nucleus, this is atom. So nucleus is 10 raised to power minus 15. This is 10 raised to power minus 10. So it will become 10 raised to power minus 5. So you can say radius of atom is 10 raised to power 5 times the radius of nucleus. You can just write it here. Radius of atom is 10 raised to power 5 times the radius of nucleus. That is a very, very, very important thing for you guys. Okay? That is a very, very, very important thing for you guys. Right? So that differentiation you need to have. Right, everyone? Right? Okay? No issues, Abhijit. God bless you. Take care of yourself, yeah. Take care of yourself. We'll say that. Yes, that will be completed. Array. Obviously, that will be completed. Don't worry. Right? Okay. Yes, for that you need to see both 11th and 12th. Right? So, this is now Rutherford model of an atom. Rutherford said that inside the nucleus, he had no idea. And one thing, Rutherford discovered nucleus. Proton, he didn't discover, right? Proton, he didn't discover. He just told that protons are there inside the nucleus. Okay? Understood? So, there is, I know there is a controversy of Goldstein or Rutherford who discovered proton, but it is said that Goldstein. Why? Reason is I told you there, right? So, now one thing you need to understand here is this is your nucleus in which you have the protons. Neutrons, he had no idea about that neutrons exist. Neutrons existence was done after Rutherford model, right? So till now we know that this is protons and there are circular orbits, right? So this is drawn in this kind of format. If I draw it like this, this is positive nucleus where you have proton, and in the circular orbits, right, you have the electron that is revolving around it, right? And he gave no differentiation how the electrons are. He just said that in the circular orbits, electrons are revolving. Are they revolving at a proper distance? No idea. Are they having some energy? No idea. He just said that they are revolving around the nucleus in the circular path. That's it. Is there one path? Is there two paths? Is there three paths? No idea on that. Right? So that is your Rutherford model of an atom. He defined circular paths, but he never fixed that at this distance, this should be the energy. That Bohr model will tell us, right? That thing will, we will know after Bohr's model. He will define the orbits at certain distance. Till now, there is no definition that at certain distance. He just told that circular path, that is called orbits, right? So we can say that postulates are positively charged, positive charge, and most of the mass of the atom was densely concentrated in extremely small region called nucleus. Second is, that's why whenever we talk about atomic mass, we talk about what is there in the nucleus. Okay? Till now, they think that there is proton. Rutherford thought that only proton is there in the nucleus. Arey, what's the big deal? Right? He told that, okay, atomic mass is dependent on the proton. This is according to Rutherford. He said that all the mass of an atom is concentrated in the nucleus. And what is inside the nucleus? That will tell us the atomic mass. So we said, okay, what is inside the nucleus? Because of Rutherford, we know that it is proton. So it might be dependent on only the proton. But after that, because it was not getting equal, experimental data of atomic mass and this data of atomic mass was not equal. So that's why scientists observed that there must be some other particle also which is having no charge, which is having some mass that is equal to proton, because the mass was always coming double or slightly more than double of the proton. That means there is some particle inside the nucleus apart from neutron which is having mass equal to proton. Is that clear, guys? Is that clear? Okay. Now, this means that here I can say atomic mass is nucleus, but now after Chadwick discovered neutron, right? Then we got to know it's actually neutron plus proton, and that's how we know the atomic mass, right? Now, whenever I ask you mass number, atomic mass, if you remember from some basic concepts of chemistry, we understood that that is neutrons plus protons. Okay, got a clear idea on this, guys? That is clear, everybody? Now, let's talk about this thing here, that is nucleus. Nucleus is surrounded by electrons that move around the nucleus. Around the nucleus, it is moving with very high speed in the circular paths called orbits. Now, he said that it's just like our solar system, right? Like we have sun, electrons, I'm saying. Earth is revolving, all the planets are revolving around the sun, right? So in a similar way, we have electrons that are revolving around the nucleus, right? Next is, electrons and nucleus are held together by electrostatic force of attraction. Now, he also pointed out that electrons are revolving around the nucleus. Nucleus is positive, electron is negative, and they have a force of attraction of positive and negative. That's why they are revolving around them, right? But there is a major drawback of Rutherford. But before the Rutherford drawback, tell me one thing. It's like, ma'am, you explain one theory, there is drawback. You explain one theory, there is drawback. So, you know, in the initial days when we were trying to understand atom, these things were happening. Just like right now, what is the revolution? What is the revolution right now? You guys are engineering students. You're going to be engineers, right? So you must know this. Today is the world of AI, artificial intelligence, right? So it's not like artificial intelligence is perfect now. You see any photo, any video you generate, try to generate it if ever you get time. I also love doing that, right? So try to generate any video, anything from the Chat GPT or Google Gemini, anywhere you do that. What you will observe that they make mistakes, right? Sometimes you ask them what is the syllabus of JEE mains, they will give you a wrong syllabus, right? So it's not that you can properly rely on them right now, because right now they have drawbacks, but after some time they will not have. After 10 years they will not have, right? So everything, because right now you are seeing the development of AI, so you can visualize that at that time they were developing, they were trying to understand atom. So that's why some theories were there, some failed, some got rejected, and some we actually study. Okay, so that is the whole scene behind all these theories. Okay, yes, everybody. Chal. Yeah, when the syllabus will be over, I think by end of November or mid of December, we'll start with the question practice and all, right? Don't worry about that, right? So now let's talk about this thing, that is drawbacks. What is the drawback, right? So why this theory is now neglected? We don't talk about this. Is not the real structure of atom. The reason is, one thing you all know, that in a circular path, anything which is in a circular path, if speed is same, if I am saying the speed of electron is same, direction is changing at every point. Direction is changing at every point. Now, if direction is changing, speed is same. So what is changing here? That means, can I say velocity is changing? There is change in velocity. There is change in velocity. Change in velocity is nothing but acceleration. Now, this is acceleration. Now, we are saying that when an electron is moving in circle, it is in the accelerated motion, right? That's what Rutherford told. Now, everyone else was like, okay, this is changing, it is accelerated motion. Then tell us one thing. If this is an accelerated motion, then how can you say that this is by Maxwell? He said that every single thing that is in the accelerated motion, if you have any charged particle, this is the physics theory, that if you have any charged particle that is in the accelerated motion, that charged particle is not going to stay as it is going to lose the energy, right? So Maxwell said that any charged particle under influence of attractive forces should continuously radiate energy. If this is so, electron will also radiate the energy. You are saying electron is like, but no, he said that no, electron will start its path like this, it will lose energy, lose energy, lose energy, lose energy, lose energy, and it will fall into the nucleus. Tell me, is this happening in reality? Who am I? Am I made up of atom? Yes. Are you made up of atom or not? No, ma'am, we are made up of cells. Cell is also made up of atom, no? Right? So everything in the universe is made up of atom. If we are saying atom is not stable, we are questioning our stability. So we all should like die the moment we are born, right? But this does not happen. We are all living beings. We are there. We are stable. It's not like your ma'am is standing here and from one atom is collapsing, here one atom is collapsing, here one atom is collapsing. It's not like that, right? This is not happening. So atoms are stable, right? So this puts a very big question on the stability of the atoms. How come they are stable? How can you say they are stable? That is a big question on the stability of the atoms, right? That is the first thing. Second drawback of Rutherford is it says nothing about electronic structure. Like how electrons are arranged. You are saying electrons are moving in the circular orbit. How they are moving in the circular? 2 electrons, 3 electrons. Do they have some definite path? Do they have some definite energy? Nothing was told by Rutherford. That we will discuss in Bohr model. It was told by Bohr, right? Not Rutherford. Okay, everybody? Tell me one thing, 2 models are done. For Bohr model, we need to discuss a lot of things, right? Only then we can jump to Bohr model. And this chapter is going to be little lengthy. So you need to be very, I would say, fully dedicated to learn this chapter if you want to do this in detail. Right, everyone? Yes. Let me know. Yes, everyone. And those who are worrying about syllabus, you can check out my record. Right? I never, like, it's never that I tell students that I'll complete the syllabus, I don't complete. Never ever I do that, right? So I'll complete the syllabus, I'll do the revision, we'll do practice of questions, don't worry about that, right? All you need to do is attend the lectures, attend the classes, right? And solve the DPPs, questions, all of that, right? Okay. Now let's see this JEE Mains 2021 question, that is, if the Thomson model of an atom was correct, then the result of Rutherford model would have been. I just showed you this thing. I just showed you this thing by a simulation. If Thomson model was correct, then all the alpha particles should go uniformly. It's not like someone is going straight, some are deflecting, some are bouncing back. That should not be there, right? So all alpha particles pass through without any decrease in speed, are deflected over wide range of angles. Alpha particles get bounced back. Alpha particles pass through gold foil, deflected by small angles with reduced speed, right? If Rutherford model is not true, if we assume that Thomson model is true, then all the alpha particles will move here in a path, and what will happen? Alpha particle passes through gold foil deflected by small angles and with the reduced speed, right? All the alpha particles, oops, all the alpha particles will have the same nature. They will have the same nature. Now, ma'am, how come they are having the same nature? Why they are having the same nature? Because all alpha particles are having the same nature because the uniform distribution is there, right? So positive charge is uniformly distributed here, right? So if they are facing deflection, all of them will face same kind of deflection, not bouncing back because it is uniformly distributed, but yes, small kind of deflection they will face, but uniformly, right? So alpha particle pass through gold foil deflected by small angles with the reduced speed because there is no empty space, so speed will be reduced. Okay, yes everybody, right? Okay, Rama Raju, that we are going to discuss, right? That is not a part of today's lecture, but in this chapter itself we are going to discuss alpha, beta, gamma rays, everything, right? So next is you have isotopes, isobars, isotones, diaphers, isosters. So these are 5 major ISO that we are going to discuss. Okay, everybody. These are 5 major ISO that we are going to discuss in today's lecture. Yes, everyone. So let's talk about this. If you talk about isotopes, now what do you mean by ISO? ISO means same. So in all these cases, something is same, something is different, right? And based on these definitions, based on examples, a lot of questions are asked on not only JEE Mains but advanced as well. So you need to understand this, right? So talking about isotopes, they are variants of an element in which atomic number will remain the same. Atomic number is same. Carbon is having atomic number 6, but the atomic mass will change. And if you remember, those who don't remember the representation of an element, I'll just show you that. Representation of an element is, this is the element, then this is A and this is Z. Now, what is this A? What is this Z? Anybody in the chat box? E is mass number. What is this A? Same atomic number, different atomic mass. Very good, Gokul. Very good. So, this is mass number, right? This is atomic number. This is atomic number. Now, when I talk about mass number, I talk about atomic number, right? In that case, what is a very, very important thing that we need to see? Atomic number is always equal to number of protons, and mass number is always equals to neutron plus proton. That you need to understand, right? Based on this, we are going to apply the same concept everywhere, right? So, and one more thing to write down here. What is nucleons? Nucleons are neutron plus protons. Okay? These are called nucleons. That is there in the nucleus. Okay? That is also called mass number. That is also called atomic mass. And number of neutrons are also calculated by A minus Z. Because A is N plus P, Z is P, so it will cancel, it will give you neutrons. So answer is, number of neutrons are also calculated by E minus Z. Yes. And tell me one thing, can we say that atomic number is equals to number of electrons? Can I say that atomic, or can I say that Yes. Atomic number is equals to number of electrons. Can I say that? Is that a correct statement? This is correct. This is incorrect as well. See, if you talk about a neutral atom, in that case, electrons, protons are same. So in that case, atomic number is equals to electron. But if you talk about an atom which is not neutral, an atom which is anion, right? Which may be an anion that is gaining the that is made by gaining the electron, and a cation which is made by loss of electron, right? So any of this you have, atomic number in that case is not equals to electron. Okay, yes, it is just applied for a neutral atom. Now let's talk about isotopes that we are going to see throughout the chemistry, in organic chemistry as well, in inorganic chemistry as well. Isotopes is a very basic definition, right? So isotope says that here atomic number is same. That means Z is going to be same, right? That means protons are going to be same, but A is different. Atomic mass is different. That means A is nothing but neutrons plus protons are different. If addition of two things is different, but protons are same, that means neutrons will be different. So there are different definitions of isotope. First definition is that you can say that atomic number is same, mass number is different. Second definition is you can say protons are same, neutrons are different, right? Third definition, these are the two definitions that you have. Similarly, you have carbon, oxygen. Other examples can be you have hydrogen 1 isotope, hydrogen 2, hydrogen 3. Now hydrogen 2 is nothing but it is deuterium, there is tritium, that is hydrogen 3, right? Then after this, when we talk about the next part, that is other example can be oxygen 16, oxygen 18. These are other examples of the isotope, right? Okay. Yes, everybody, hydrogen, deuterium, tritium, very good. Now, next is isotones, right? See, remember this thing here. It is chalo, I'll give you in the end, I'll give you a trick to remember this as well. Now, just try to understand what I'm telling you. Isotones, ons, N. So this means neutrons are going to be, isotons are nuclides. That means nuclei of atoms that have same number of neutrons but different number of protons. That means here I can say, for example, I talk about this example here. Nitrogen, let's talk about nitrogen and carbon here. Now tell me, nitrogen has how many? This is the atomic number is 7. Here atomic number is 6, right? So for nitrogen, what are the protons? Protons are 7, right? Electrons will also be 7. Neutrons will be 15 minus 7. That is your neutron. So it is going to be 5, 6, 7, 8. That is going to be 8. Okay. For carbon here, for carbon 14, this is for nitrogen 15, right? So it is going to be, proton is atomic number, electron is also same. What is neutron? Neutron is 14 minus 6, that is 4 plus 4, that is 8. So now can you see that neutrons are coming out to be same. Neutrons are 8. But protons are different. Proton is 7, proton is 6, right? So that means this falls into the category of isotones. Now, next part is, if I am saying that this is falling into the category of isotones, then I can say one more thing here. That is, if it is falling into the category of isotones, then can I just write neutron is nothing but A minus Z? So can I say Z is the same, A minus Z is different. Just like here you had Z is same, no, Wait a minute. This is the opposite I have written. Z is different and A minus Z is same. See, just like here you have written in the form of Z and A. So, in terms of proton, neutrons, you remember in the form of this and this also you should remember. Z is same and A is different, right? That means neutrons are different here. In this case, protons are same, protons are different, neutrons are same, right? That means Z is different, A minus Z is same in this case, right? So you should remember both the definition, neutrons, protons as well. You should remember Z and A minus Z as well, because anything they can ask you based on statement-based questions, right? Next is isobars. Now, any idea on that? This is exactly opposite of isotopes. Exact opposite of isotopes. Students, any idea on this? You can see it over the screen as well. You can see it over the screen as well. Isotope is, you have atomic number same, mass number was different. Here atomic number is different, mass number is same, right? So in these kind of nuclides of different elements that have same mass number but different atomic numbers. So you have a different atomic number. So in this case, can I just justify one thing here, that if you have a different atomic number, this is in terms of A and Z, how do you write it? So firstly, let's verify this. Is this a atomic number or not? Sorry, is this a isobar or not? So this is 40, argon is going to be argon, potassium, this is 19, this is 20, right? 19, why I am writing it. This is 18, argon is 18, this is 19, right? Okay. Now, let's talk about this thing here. In this case, you have the mass number is same, but the atomic number is different. You can see that mass number means A. That is going to be same, but Z is going to be different. So I can see this here as well. I can see this here as well, that the atomic number is different, mass number is same. So we can identify it here. We don't need to do any calculation here, right? We don't need to do any calculation here, right? Okay, everybody. Now tell me if there is any problem in this. Any problem? Yes, students, any problem? Any problem over here? Because next two isosters and isodiaphers are little on the lengthier side. So that will be different for you, right? But before that, let's do these. See, these three are basic. Isosters and isodiaphers is, if you are preparing for a good level of exam like JEE, then you have to go through that as well. Otherwise, these things are there in CBSE as well, in board examination or simple state examination, this much is enough. But if you're preparing for national level exam, then you have to go through isosters, isodiaphers as well, right? So you can choose accordingly, right? Now, let's learn this thing, right? Isotones, N is there, so that means neutrons are same. This is isobar. This is A, that means bar, atomic mass is same. This is A is nothing but your atomic mass symbol, right? That will be same. Isotope, P means proton is same. That means Z is same. So that's how you remember this. Okay, that's how you just remember what is same. Just remember what is same. Isotone, N is neutron is same. Isotope, P, proton is same. Isobar, R, mass is same. Atomic mass, that's a symbol of atomic mass, right? So that's how you can remember these things, okay? Because this can get quite confusing to you, right? You can take a screenshot here because, you know, this is very important, right? You can revise it whichever when you have time. And the PDF of this session will be provided in the description box. Don't worry about that. Okay, now let's move to isoelectronic. Isoelectronic, the name says it all. Iso, same. Electronic, electrons. The electrons has to be same, right? What we are discussing here, that the electrons will be same, right? So isoelectronic means you have different elements, atoms, ions, cations. The electrons has to be same. So let's talk about this one. In these two cases, can I say that here you have sodium. Sodium is 11 atomic number. Sodium positive is 10. Fluorine is 9. Fluorine negative is 10. So that means electrons are same here. Ma'am, protons are same or not? This is a nucleus. This is the electrons, right? You can never add a proton into the atom. You can't do that, right? You can add electron, you can take electron. By that, you will have cation and anion. So, in this case or this case, the protons are going to be same only. Proton is going to be 11 only. So, similarly, proton will not change here. Proton will be 9 only. Which will change? Neutron will not change here. Neutron will also not change. Only the electron is changing in this case. Proton and neutrons will remain same. For an element, it's cation, it's anion, it will always remain same. Right? So these have same electrons. So that's why these are called isoelectronic species. Now, wait a minute. Let me just get you into detail of one very important thing about isoelectronic species. That is the size of isoelectronic species. Okay, so let's talk about the size of isoelectronic species. This will be more in detail. You will study this particular thing in periodic classification, but let's study it here as well. So, size is basically related to directly this you will see that like more detail, because in periodic classification we study the properties. So in detail you will study about this in inorganic chemistry as well. So size is, see, for example, let's take an example of sodium, right? So this is sodium, right? This is fluorine. Now if you see, this is sodium positive, this is fluorine negative. Electron is 10, here electron is 10. Here proton is 11, here proton is 9. Now tell me, proton is attracting the electron, right? Now here 9 people are attracting 10 electrons. Here 11 are attracting 10. Which will have a stronger electron, like attraction? So proton is like parents, right? His parents are very, very lenient. They are attracting with not so much force. You have to come here, like, yes, why are you moving? Why are you going here and there, right? So it's already 7 p.m. You're still outside the house, this and that, right? His parents are like that. It's already 5 p.m. You are still outside the house. Give me your phone. I want to check your phone, right? His parents are not so strict. They are like, come home safely. That's all we want, right? So they are not able to attract the electron with that much force, because electrons are moving here and electrons are like chilling, right? Moving here, there. Proton are like locked in the nucleus, right? So that's why it is attracting with a stronger force. That's why here size is smaller as compared to this size will be large. So that was the concept behind it. In detail, we will talk about Z effective, nuclear charge, all of that in periodic classification, right? And after structure of atom, I am going to start periodic classification only, right? Because right now my motto is to do those chapters which will polish your basics, so that your gateway for class 12th can also open. You can start watching class 12 classes as well. Equilibrium, thermodynamics, they are not so related. Thermodynamics though very rarely related, but without it is related, definitely it's chemistry, but the way structure of atom, periodic classification, chemical bonding are related, it's to next level. You can't actually go through 12th syllabus without doing these chapters, right? So now we will study this in detail in our periodic classification, but for now what you remember, size is directly proportional to anionic charge and inversely to cationic charge. So you saw now, cationic charge inversely proportional, right? So ma'am, I am not able to understand this. Please explain all these things. If you're not able to understand, don't worry. I'll have full-fledged 30 minutes lecture on this thing only, right? So till now, you just remember this thing. For example, they have given you Al3 positive, F negative, uh, Ne, sodium positive, then O2 negative, right? These things are given to you, and they are saying, let's say they have given you Mg2 positive. These things are given. And they are asking you to put it in the format of size. How do you put it? By simple trick. Okay. So what is that trick? The size is going to be more the anionic charge, more will be size. So maximum anionic charge is 2 negative, then it is F negative, right? Then neutral is neon, then more the cationic charge, less its size. So maximum cationic charge is Al3 positive. So that will have minimum size. Then you have Mg, then you have sodium. Arey yaar, I don't have space to write it. So this is neon, then you have sodium, then you have magnesium, then you have aluminium. So this is also a very, very like highly asked question from, you can say this is from periodic classification or structure of atom. This we will do in both the cases, right? Now, next is this isostar is we are going to do this here only. Isostar I'm not going to repeat in any chapter, right? So isostar and isodiaphers. Isostar is what? Isostars are molecules or ions that have same number of atoms and same number of valence electron. Very, very important. Same number of atoms, same number of valence electrons. Let's talk about some examples here. Here, firstly, let's talk about this particular example here. That is O2 negative and neon, right? So one by one, I'll talk about the valence electrons here, right? O2 negative, right? Why this is important? Because more knowledge is required for this one, right? So oxygen is one atom, this is one atom. Now that means number of atom is valid here. Let's talk about valence electron. Okay, for that, tell me the difference between valency and valence electron. What is the difference in valency and valence electron? Anybody in the chat box? Ma'am, so F is larger than sodium? Yes. F negative is larger than sodium positive. I'm not saying fluorine is larger than sodium. I am saying F negative is larger than sodium positive. If you take out one electron from fluorine, if you add one electron to fluorine, you take out one electron from sodium, then F negative is larger than sodium positive. Here we are talking about the isoelectronic species. All of them have, this thing is applicable only when you talk about species which has same electron. If they don't have same electron, this particular concept will not be applied there. Only for the species which have same number of electrons, this is applicable. Okay, Vijayan? Yes? Okay. Now, let's understand this thing, right? What is the difference between valency and valence electrons? See, valency is how how many electrons you want to gain or how many electrons you want to lose, right? For example, this you will study in more detail in periodic. See, that's how chemistry is interrelated with each other, okay? So let's say, don't get into this, ma'am, how you got it if you're getting confused here. So let's not talk about this thing. Let's say, in chemical bonding, we will discuss about something called stability, that for to make something stable, it has to achieve something. Like to get your admission, you have to like clear the cutoff. Similarly, they have to clear their cutoff as well. To clear their cutoff, they will gain electron, they will lose electron. That cutoff we will discuss in chemical bonding, right? So they will gain electron, they will lose electron. That's why atoms gain or lose electrons, right? Now, the number of electron it wants to gain, for example, oxygen will gain 2 electrons to become 2 negative. So the valency is 2, right? For example, sodium will lose 1 electron to become sodium positive. The valency is 1. But valence electron is entirely a different thing. We are not talking about how many electron it will lose or gain. We are talking about how many electrons are there in the outermost shell. Let's talk about that. Okay. So when you will do electronic configuration, this will become more clear to you. That is the last part of this chapter. But as of now, I'll just tell you this is O2 negative. So total it has 8 electrons plus 2, that is total it has 10 electrons. Neon also has 10 electrons, right? So definitely they are isoelectronic as well, that we can say. But are they isosters? For that we need to see O2 negative with 10 electrons, the outermost configuration will be 2. Then it will be, you can say 1s2, 2s2, 2p. This is 10 now. So it is 6, 7, 8, 9, 10, 6. Like this it will be. Okay? If you're not able to understand this thing, then I would advise you just do one thing. This is 2, then 2, then 6. 2, 2 you have to do. 2, 2, then how much is there? 6. But you know, when you will study electronic configuration, this will become more clear to you. So I would write electronic configuration only. Don't say, ma'am, how it is, how you have written this, that I'll teach you. Right now, just focus if this thing is given to you, how you will identify how many electrons are there in the outermost shell. For neon, it is again 1s2, 2s2, 2p6. So can I say that the number of electrons in the outermost means when this 2, 1, it is same. This also we will discuss in the last part of this chapter, right? This is the outermost shell. Okay, this is the outermost shell. Here also it has 8 electrons in the outermost shell. Here also it has 8 electrons. So that's how we can say that it actually has the same number of valence electrons. Okay, right everybody? Acha. Now, I'll give you one more example here. Okay? Just to be clear here, because you need one more example. Let me see if that example applies on also. Even I'll see in front of you only. I think Cn negative, and let's discuss CO. Let's see. I think it should be, but let's see. Okay. So here it is. Number of atom is 2, number of atom is 2. Okay. Now let's discuss number of atom is 2, number of atom is 2. Carbon is here, here also you have carbon. This is nitrogen negative, this is oxygen, right? So if you talk about, we are not going to discuss nitrogen negative, rather let's discuss nitrogen and this is oxygen, right? Okay, because overall it has negative here. So when you talk about this, this is carbon which is having 6 atomic number, that will be nothing but 2, 4. Nitrogen is having 7 atomic number, that will be 2, 5. I think this is, you know, you have discussed this in 9th class, KLMN, but in 11th class, we are going to discard that electronic configuration. We are going to apply the method of 1s2, 2s2. So I am not writing that again and again because I know you will get confused, right? So carbon is 2, 4, it is 2, 6, 5, because it is like this, 2, then you have the other one, right? So this is 2, 4, this is 2, 6, right? It's like this, you have to complete 2, then 8, then 8, then 18. This is what you have to complete. In this set, you have to complete. This is the first shell, this is second shell, this is third shell, this is fourth shell. Now I'm telling you by your previous knowledge of 9th class only, 2, 8, 8, 18. It's like this, okay? But if you are still confused here, I got your back. With electronic configuration, this will be simple, like a butter, it will be simple, right? So this will be carbon, again it is 2, 4, this is oxygen, that is 2, atomic number is 8, so it will be 2, 6, okay? Now see this here, outermost is this shell, 4, this is 5, this is 6, this is 4. This is having total 4, this is having total 5, plus you have 1 electron, so you will say 4 plus 5 plus 1 electron, that is 10. Here you have total 4, this is 6, so valence electron will be 4 plus 6, that is 10. So that means the valence electrons are again the same, right? Okay. Tell me, students, if you have any problem here. Carbon is 2,4, oxygen is 2,6. Yes, very good. Is nothing but the electron present in the outermost shell. Very good, Kalyan. Very good. So, that is clear to everybody, right? If you have any confusion here, please ask me in the comment section in the chat box. Please ask me so that I can clarify that. I have a doubt, ma'am. Okay. Let me see. Ma'am, quantum physics, electron is standing and waves oscillate like a bubbling oscillating. No, ma'am. Undefined, what you just wrote is just a conclusion of this chapter, right? So right now, if I start solving your doubt, other students will get confused. So this is a journey, right? You are concluding something, but I am following the journey, right? So we'll get into that part as well. That's why we are discussing two models we have discussed. We have two models still left. Bohr model, quantum number. Quantum number is the final model, quantum mechanical model. And that is a very, very interesting thing, right? For that, already I'm building your base for that, right? Okay. Yes, everyone. Last, this one is simple. That is the isodiaphers, a type of nuclides characterized by having same difference between the number of neutrons and protons. The difference has to be same, right? That means, can I say A minus Z, that is your neutron, plus minus of Z, that is your proton. See, simple thing is, we are saying that neutron minus proton has to be same. What is neutron? Neutron is A minus Z, proton is Z, so that has to be same. That means we are saying A minus 2Z should be same here. So this is the thing that we are writing here. A minus 2Z has to be same, right? This is the thing. So you can say A minus 2Z, you can just say neutron, A minus 2Z, you can say this is A, this is 2 of Z. So you can say 238 minus of 2 into 92 will be equals to, this is written opposite, huh? This is written opposite. 234 should be here. It should be 234 here and 90 here. Okay? 234 and this should be 90. So this is equals to 234 minus 2 into 90. Okay. So this is 238 minus 90, 90, 184. Right. This will be equals to 234 minus 180. That is coming out to be 54. And this is also coming out to be 54. Isn't it equal? So that means they are going to be equal here. Right. Yes, U is nothing but uranium and TH is thorium. Thorium. Okay? Chal. Done. Okay. Yes. Got it? Very good. Yes, yes, bilkul. So now what you have is JEE 2024 question that is based on, in case of isoelectronic species, the size of F negative and neon and Na positive is affected by which of the following? Can you tell me that? Right? Ma'am, quantum number when? Firstly, we will discuss about electromagnetic radiation, then photoelectric effect, black body radiation, Bohr model of an atom, de Broglie hypothesis, Heisenberg uncertainty principle, these things. Then we will go towards the quantum mechanics model. It's a lengthy chapter and every single thing about this chapter is important, right? Okay, and we have started the important part. First lecture, not so many questions are asked, but from today's lecture, shoot up of questions is there, right? So in case of isoelectronic species, the size of F negative and neon, and this is affected by which of the following? Size is affected by which of the following? JEE means 2024 question, right? See, I told you that electrons will be same, protons will be different. So the attraction, the effective nuclear charge is going to be different, right? So electronic interaction, none of the above, because the size is same. No, it will be affected by the nuclear charge here. So answer is going to be A is the correct answer, right? Because nuclear charge means how much nucleus is attracting the electron. That is the nuclear charge. So if electrons are same, proton are different, right? Let's say you have 10 electron, 10 electron, 10, 10, 10. Here you have 9 proton, 10 proton, 11. This is 12. This is 30. This is for fluorine. This is for neon. This is for sodium positive. This is for magnesium 2 positive. This is for aluminium 3 positive. Let's say you have 8 proton and 10 electron. This is for O negative, right? Can you see in all these cases the protons are fluctuating? That's why this has the maximum size, and here the size is going to decrease. The size is going to decrease here. Why? Because nuclear charge is fluctuating. Here, let's say it's like a tug of war situation. You have 8 people here, you have 10 people there. Always in the team B. Let's say this is team A, this is team B. Chalo, this is, we say team B, this is our team A. So in team A, in my team, it is differentiating, right? Team B is always 10. So if in my team I have 8 people, they will not be able to pull the 10 people. 9 will also find it difficult, right? So the size will not decrease. 10 will further increase, so size will slightly decrease. 11 will put more pressure, it will decrease. 12 will put more pressure, it will further decrease. 13 will pull more pressure and it will further decrease. Right? It's like a tug of war situation, right? Okay. Next is, which of the following is isoelectronic species? Choose the correct answer from the codes given below. Which of the following is isoelectronic species? And let me see how many people actually like this session. Huh? Non-stop I'm doing just for you guys. Why don't you like the session? Like this session, share this session with your friends. Right? This also, gives us inspiration to do more for you, right? Because efforts, love is not one-sided, it's two-sided, right? Ma'am is putting in effort, so you also have to put in efforts. What efforts? Do your homework, right, regularly. Care that ma'am has given you DPPs. Share this session on your WhatsApp, on your Instagram, if you're on it, right? You have to share that, right? Like this video, right? This all you can do. Comment. That you don't have to tell anyone to comment. You need to comment down, right? So, let's do this. Which of the following is isoelectronic species? Number of electrons should be same. NH3, CH3, NH2, then you have NH4 positive. So 1, 2, 3, 4. Nitrogen has how many electrons? It has 7 atomic numbers, so number of electrons are 7. Hydrogen is 3. Carbon is 6 plus 3 minus 1 because of this positive. This is, nitrogen is 7. So it will be 7 plus 2 minus 1 or plus 1. It will be plus 1 because you are adding a charge here, right? This is 7 plus 4 minus 1. So what is the value here? Value is, this is 10, this is 4, 6, 7, 8. This is 7, 8, 9, 10. This is 7, 8, 9, 10. Again, it is 10. So 1, 3 and 4 have the same number. 1, 3 and 4. So answer will be B is the correct answer here. Okay, everybody. How to calculate the number of electrons? If they are getting same, then it will be the isoelectronic species. Right? So this next one is, consider the atoms that you have here. Answer the following questions here. Okay, so these are the atoms. You have to answer the following questions here. Let us see if you're able to identify these things and if you're able to answer this or not. Let's see that, students. If you're able to answer this, that would be great. So let's see. So first is, consider the atoms that you have here. Answer the following situation here. What atoms are isobars? Anybody, anybody, anybody. What atoms are isobars? Isobars, mass number is same. Mass number is same for which of the following? Here mass number is same. These three have same mass number. So can I say oxygen 18, fluorine 18, neon 18 have the same mass number. They are the isobars. What are isotopes? P. Protons are same. Ma'am, but proton is not written there. Array, proton is the atomic number, right? So oxygen is 8. This will be 8. Fluorine is 9. Neon is 10. Neon is 10. So which of the following has same, which of the following are isotopes which have same atomic number but they have different atomic mass? But they have different atomic mass, right? So the set is, one is oxygen 16, oxygen 18. The other set is neon 18 and neon 20. Right, that is the set that you have here, right? Okay, very good, very good. I can see that over here. Very good, Taruna, very good. So you guys are answering. That is making me very happy. Do isobars have same or different physical properties? Right, everybody? Do isobars have same or different physical properties? That you have to answer here. See, isobars will have same or different physical properties, right? Isobar means something which has same protons, right? Physical property is actually the inner core of that electron. So they will have same, because inner core is same, protons are same, but they will have same physical properties, right? Which have the same number of neutrons. Which will have same number of neutrons? A minus Z. So this is A minus Z is 8. This is 18 minus 8 is 10. 18 minus 9 is 9. 18 minus this is 10. 18 minus 10 is 8. 20 minus this is 10. So, same number of neutrons will be there for oxygen 16 and neon 18. And this is the one set. Other set will be neutron is same for neon and not neon, it is 8, 8, 10 and 10. For oxygen 18 and neon 20, it is same. Okay, so these are the two sets which have same number of neutrons, right? Okay. Next is, which atom have the same number of valence electrons? Valence electrons are same for which of the following? That depends only on the atomic number, right? So valence electrons, the simple thing is that will be same for oxygen 16, oxygen 18. This is the first set. Second set is neon. Number of valence electron same means number of electrons has to be same, because there is no anion here that valence electron will automatically change. So oxygen also has 2 and 6. This oxygen also has 2 and 6. Neon has 2 and 8. So this neon 18 and neon 20 will have the same number of valence electrons here. Okay. Yes, everyone. Okay, so this you can see this over here, right? All the answers are there, right? Okay. Yes. Okay, now let's talk about electromagnetic radiation, electromagnetic waves. Because students, it's already 1.5 hours. So let's see, because black body radiation photoelectric effect itself is a very, very big part that we are going to cover. So you let me know if you want to, because this full we can't cover, right? Full electromagnetic radiation, black body radiation, and photoelectric effect, Planck's quantum theory, we can't cover in just one go. So what I'll tell you, let's understand electromagnetic radiation. Let's understand what are the terms of electromagnetic radiation, and black body radiation, photoelectric effect, and Planck's quantum theory we'll do in the next lecture. Okay? Yes, that works, right? Otherwise your brain will shut down, right? Okay, so let's do this here. Let's do this here. Number of neutrons have same number of neutrons. Wait a minute. Same. Da, da, da. Okay. Very good. Very good. Very good. Very good. Very good. Very good. Chal. Now let's talk about electromagnetic radiation. Something very interesting. We are going to start, students. No more hypothetical things. Something which we see in real life. This chapter is definitely very interesting, right? If you have a right teacher to teach you, this chapter is very interesting, right? Otherwise, this chapter will be like you won't be able to understand, right? So, yes, everyone. Till now, how is the class? Till now, how is the class? Right? You have understood everything. Is the class right? Your brain is still working. It is still in the working zone, or is it shutting down, ma'am? Is it sleeping? Is it sleeping? Or is it right now awake? Yes, everybody. I'm waiting for your answers in the chat box. So, I want to chit chat with you also. It's not like I always like a robot. I can come and just tell you this and that, and just go. I can't do that, right? I need to like know you also. Okay, let me know in the chat box like where, like which class you belong to. Class 11, class 12, or I have droppers also in this class. Let me see. Let me see. Yeah, let me see. Do I have class 11, class 12? And I know there are class 9th, class 10th students as well. So do let me know if you're in class 9th, class 10th, what is there? Super, ma'am. Awesome, awesome, awesome. Awesome. Great. So let's see that. I'm waiting for your answers. Let's see that. Let's see that you guys are typing, huh? Dropper, ma'am. Okay. What about others? One, Kocha, dropper squad. Dropper squad, I have also put a short on for dropper students, and I have also put one very, very important thing, that is your what I say, backlogs like completion, and then dropper, what exactly are the things that you guys are doing wrong? Because as a dropper, there's so many things that you need to think about, right? Dropper strategy and student who are fresher, it's completely different, right? Yes, 12th, ma'am, dropper, class 11th, 9th, 10th, any student from that class. Very few students are typing. You lazy people. Lazy people. Too lazy you are to type. Ma'am, we can send you a voice note, ma'am. Don't ask us to type, ma'am. You have to type, guys. Right? Otherwise, I'll feel like I'm teaching these walls, right? I don't want to feel like that. When I don't reply, then you're like, ma'am, why you're teaching like a robot? Why are you not replying? Why are you not replying to our chats? I'm a neat aspirant watching your video. Perfect, Nikki. Okay, great. Great. Your chats are so slow, guys. It's so slow. Right? I can actually complete one topic by the time you're writing something. So slow your chats are. I think you guys don't like me. Huh? You guys are not interested in talking to me. Right? You guys are like, ma'am, we don't want to talk to you. Right? We don't want to respond to you. Very sad. Very sad. Do I look like someone who will just scold you if you write? Just tell me what exactly is the class that you are from? Are you robots? No, right? So type something in the chat box. Hello, Prajan. Not like that, ma'am. Okay, you just joined now. What about others? Class 11. Okay. Okay. Yeah, your chats were so slow. Now I have lost the mood of asking you which class you belong to. Right? I am also like sometimes I feel like asking you something, then I see your chats are so slow. I feel like okay, I should like just focus on the studies. I should just tell what is this and just say bye bye, take care. That's it. Hmm? Okay. Prajen, you are from which class? Class 11 will JEE means in 12th. Will crack JEE in 12th. Very good. Very good. So I can see most of you are in class 12th, right? And great. So I say you are so special. Thank you. You are also so special. So let's see this electromagnetic radiation. See, everything around us is, most of the things are electromagnetic radiations. So what exactly is electromagnetic radiation? See, can you see this particular thing? Can you see this pen over here? Can you see this pen over here? Do you know this pen also has inside it some electromagnetic radiations, right? The light that is falling, it is also having some electromagnetic radiations, right? The everything, like everything around us is having some electromagnetic radiation. But ma'am, what exactly is electromagnetic radiation? See, it is electric field plus magnetic field, right? So we all have wave nature as well, that we will talk about. See, this chapter is slight confusing, so what you will do, we will talk about different things that will connect the dots in the end, right? So let's say this is the wave nature. We are talking about the wave nature here. This is the propagation of the wave, right? See, if I say this is the propagation of the wave, then what will happen? It will happen like this, like this. If this is the direction of propagation of wave, then electric field will be perpendicular. Maximum question they can ask you this one, perpendicular and parallel, right? This thing is parallel to the propagation of wave. And this is the magnetic field, which is parallel, I am saying perpendicular. This is your propagation of wave. This is perpendicular to electric field. This is perpendicular to magnetic field. And electric and magnetic field, if you see this here, this is magnetic field, this is electric field. They are also perpendicular to each other here. You can see that. They are also perpendicular to each other, right? So what is the definition? That magnetic and electric field which are perpendicular to each other and they both are perpendicular to the propagation of wave. This kind of set we call electromagnetic radiations. Okay, right? Okay, thank you so much. Thank you, Rama. You are like brothers and sisters to me, right? So I know that if I don't care, who will care, right? So world is already very harsh for you, so I don't want to make it more harsh by being a harsh teacher, right? So let's see this. You have three things: magnetic field, electric field, and wave propagation. All three are perpendicular to each other. This is what electromagnetic radiation is, right? I know you are still not clear on this. The more detail is there in physics, right? In chemistry, we don't have that much detail. You will see some topics are overlapping in physics and chemistry, right? So here, if I say this is the propagation of the wave, this is where the wave is propagating, then we can say the magnetic field will be on this side and the electric field will be on this side. That is how they all are perpendicular to each other, right? So electromagnetic field has electric field, magnetic field, right? Now let's understand the characteristics of the wave. So wave has so many characteristics, like we have amplitude, we have crest, we have trough, we have wavelength, we have wave number, we have frequency, right? In all the formulas, you're going to use these terms, right? So let's understand that. When I talk about this is actually a wave. This is the positive direction, this is the negative, positive, negative, positive, negative. So the positive part, we call it as crest. The negative part, we call it as trough, right? So positive part is crest, negative part is trough. Not important for your chemistry answers, right? Not important. What is important? To understand amplitude. This particular thing that I'm talking here is called amplitude, right? What is amplitude, guys? What is amplitude? Amplitude is from this particular x-axis till the highest point of the wave. What is the length? What is the height? That is called the amplitude of the wave, right? Similarly here, this to this, what is the height? That is called the amplitude. Usually this and this will be same if it is a symmetrical wave, right? Now, what is a wavelength? Wavelength is represented by this lambda. This is called lambda, Lambda, right? This symbol is called lambda, right? Lambda is a representation of wavelength. What is the length of the wave, right? And for that, what we want to see? Length of one wave. For that, either you see distance between two crests or distance between two trough, right? So the distance between two consecutive crests or two consecutive trough, that is called lambda. Okay, two consecutive crest or two consecutive trough, the distance that we have, this will be in meters, in nanometer, angstrom, same units of length, right? Then next one is, ma'am, what is frequency? What is wave number? See, wave number is represented by this V. See, the symbol of frequency and wave number are quite similar. Frequency is this thing. This is V and it has slightly thing like this. This is called mu. Mu. I'm just writing what we call all these things. This is lambda, right? This is called lambda. And if you talk about this V and you have a bar here, this thing is called wave number, right? This thing as such do not have any name, right? This is called V bar. V bar. Okay, so this is how I am going to represent this. Lambda, mu, V bar, right? Lambda is for wavelength. Lambda is for wavelength. This frequency is, mu is for frequency. And wave number is wave. This V bar is wave number. Okay, so this is how you represent it. Now let's talk about, ma'am, lambda you have told us. But ma'am, what is this frequency and wave number? Let's talk about that. Okay, let's talk about, right? When does the class end? Maybe next 10 minutes, right? I'll end the class. Whenever you want, I'll end the class, right? If you have more energy, I'll teach you black body radiation here. If you're like, ma'am, please, this is enough for today, then I'll teach you black body radiation, Planck's quantum theory, and photoelectric effect in the next class, right? But black body radiation is a very important concept. Usually students are not able to understand that. So if you're like, ma'am, my brain is now on hold, please give us some time to relax, then I'll teach this on the next class, right? So, characteristics of wave we have seen. Let's talk about, what is this frequency? Let me see if we have any definition of that here, right? We don't have, it's okay, it's okay. So let's talk about V bar. V bar, that is wavelength, wave number is nothing but it is 1 by lambda. And what is frequency? Frequency is 1 by T. That is frequency. We say, na, ma'am, what is the frequency of your lectures? I'll say, what is the frequency of you practicing, right? What is the frequency of eating outside your house, right? What is the frequency of you going for a walk, right? What is the frequency of me eating dosa? Too much. Frequency means what is the repetition? So we say that, let's say you have two things, okay? So let's say you have two things. This is one wave, this is the other wave, okay? So I'm representing it. One is like this, right? Other is like this. So frequency is in 1 second. What is, let's say this is defining, this time period is 1 second. In 1 second, this much is happening. So in 1 second, what is the frequency? Here only one wave is, one wave we have. Here it is 1, 2, 3, 4 waves we have. So in 1 second, how many waves you are able to form? That is the frequency, right? So it is the number of waves per unit time. How many waves you have in 1 unit time? That is your frequency, right? Okay, students. Yes, everybody. Now, this is another formula which relates speed of light. Speed of light is nothing but 3 into 10 raised to 8 meter per second. Speed of light is this, I think you must have heard about this thing in earlier classes as well. C is equals to mu lambda. This is not V, this is mu. This is mu. It is written like this. C is equals to, C is the speed of light, mu and lambda. So this is your formula that you must remember. It will be useful throughout this chapter, right? We'll do a lot of questions based on this particular chapter, right? I don't want to end the class. We have to end the class. What to do? Don't worry, we'll enjoy it more when we'll do one shots. It will be more fun, right? Yes. Now let's see this electromagnetic spectrum, right? So guys, if you talk about electromagnetic spectrum, okay, tell me one thing, interesting one. Are you able to see me? Yes, ma'am, you are visible to us, right? Are you able to see the radiations that are going out of my body? Are you able to see that? Can you see there is some radiation? Even I am not able to see. How will you see? Right? So you can see, ma'am, but you can't see the radiations that is going out of the body. Right? Okay. Can you see light, the tube light or the bulb in your room? Right? What you can see there? I can see that some radiations are coming out of it. But can I see full radiations here? No. Some radiations I am able to see. Some radiation means because the light I am able to see, right? If your bulb is of yellow color, you will see some yellow light. Bulb is of white color, you will see some white light, right? So these are the radiations that are lying in the visible range that human eye can see. But there are electromagnetic radiation all around us which we can't see. For example, your body is continuously emitting IR radiation. Most of the things around us are emitting infrared radiation, right? So these radiations that we are emitting, right, we are not able to see because they don't lie in the visible range, right? Now, what is exactly this range, ma'am? How this range is defined? That is defined by wavelength, right? So blue color has a different wavelength, red color has a different wavelength, right? So if you're able to see something which is blue in colors, okay, so let's see this thing, right? So this is where say your quick revision cards, right? Okay, so let's see, so colorful they are. So this is your purple color. So this, I am able to see the purple color here because this is reflecting the purple color. This is emitting the purple color. I'm able to see yellow color here because this particular area is emitting yellow color. I'm able to see something red here because this particular part is emitting the red color, right? So that means every color that I'm able to see in this particular thing, that is emitting the color, that is emitting the wavelength. This is emitting wavelength of violet color. This is emitting wavelength of yellow color. This is emitting wavelength of red color, right? That's why I'm able to see. So all these wavelengths are lying in the visible region, right? Okay. Ma'am, are heat wave also type of radiations? Yes. Right? It's just that we are not able to see this. Just tell me one thing, the filament of the bulb, right? If we talk about bulb, right? That is having heat only, right? Some heat, we can see it in the form of glow. That is actually black body radiation. We'll discuss about that, right? So just the blink, like little bit of that thing, trailer, I would say. Why you're able to see some lights, why not able to see, you're not able to see some lights? So like bulb is emitting heat, right? When it is emitting heat, some part of it, of that heat lies in the visible region. So some part of that heat you are able to see. Some part of the heat is not lying in the visible region. So that's why you're not able to see entirely. It's not like your bulb is only emitting that much amount. It is glowing because of some particular part, but it is emitting a lot of radiation that we are not able to see, right? Okay, so you are all surrounded by the radiations, right? Yes. Okay. Yes. Now let's see. Hanji, Suji, tell me what is the doubt? So when all the electromagnetic radiation are arranged in increasing order of the wavelength, decreasing frequency, band of radiation obtained is termed as electromagnetic spectrum, right? So let's see, let's talk about this electromagnetic spectrum, right guys? So what you have here is, this is gamma rays, right? After gamma rays, you have X rays, then you have UV rays, right? Gamma rays, X rays, UV rays. And what is this here? What is this, everyone? What is this here? This is your visible region that you have here, right? This is the visible region that you have here. So in this visible region, what you will have is, in this visible region, you will have VIB, Vibgyor, VI indigo, violet, indigo, blue, VAB, G, Y, orange, and red. Right? This is Vibgyor that you have. This is the visible region. And all the colors that you see around you are a mixture of these colors only. Right? This is what a human eye can see. We cannot see UV rays, we cannot see, that's why I have drawn it in black and white, we can't see them. UV rays we can't see, X rays we can't see, gamma we can't see, IR we can't see, micro, FM, AM, then you have long radio waves, we can't see any of it, right? So these gamma rays, what you need to understand for the exam point of view, what they will ask you is you need to understand which has maximum wavelength, okay? What is the spectrum order? So this is the increasing wavelength. So which has maximum wavelength is your radio waves. Which has minimum wavelength is gamma rays, right? Which has maximum frequency is gamma rays. Minimum frequency is radio waves, right? Okay. Now, like you have microwaves are produced, right? So these are radio waves for signals. Long radio waves for signals, right? Satellite signals and all of that, right? They have very low frequency, very high lambda, right? You talk about Vibgyor, this is your red has maximum wavelength. Red has maximum lambda. Violet has minimum lambda, right? Violet has maximum frequency. Why I am saying minimum, maximum, just understand one thing, C is equals to mu lambda. That means mu is equals to C by lambda. C is constant, so that's why we can say mu is inversely proportional to lambda, right? That's why when your lambda is maximum, frequency is minimum in that case, okay? Right? Okay? Yes, everybody? Clear? This is your electromagnetic spectrum. You should remember it as it is gamma X UV, right? Gamma X UV. Okay, we can also remember a trick here. Gamma's X is UV, right? Gamma's X is UV. I just now prepared it, right? Gamma's X is UV, which is visible to everyone. Gamma's X UV is visible, right? Gamma's X UV is visible. What do you do? IR, micro, radio. This you do it yourself, right? I am not getting an idea on this particular thing. This you can say gamma X UV, which is visible, right? Okay? Okay? Okay, cool. Where you guys are going, what I am teaching and what is going on in the chat, huh? Okay, so that is your electromagnetic spectrum, right? Gamma X UV visible, infrared, micro, radio. Information, micro, radio. Information, micro, radio. Gamma X UV visible, information from micro, radio, right? Where you got the information? He said gamma's X UV is visible. Who gave the information? Information, micro, radio. Randomly. I say I am giving some random things to you, right? Now let's understand electromagnetic wave theory. Chalo. Let's see this part here, right? Rest of part we'll do in the next class. A source emits energy continuously in the form of radiation. It means no change in wavelength on frequency of emitted radiation, even on increasing the energy radiation. Wait a minute. I think we have, this is black body radiation. So we'll not do it now, okay? We'll not do it now. right? Okay, sure. So this is actually the starting of black body radiation photoelectric effect, right? So we will do it in the next class. Okay. Yes, everybody, and I think you guys are exhausted now. It's already a lot of time that you guys are here, and good that you guys are consistent. Now the class will be on Saturday, and do let me know if I can take the class on Friday in the morning. I would love to take that. Otherwise, the class will be on Saturday at 6 p.m. Right? Okay. Okay, guys. Then bye bye. Take care. Now, before going, when very important information for all the students. First thing is, this is your homework that you have. This is homework number 1, that is your JEE Main 2019 previous year question. The upper stratoscope consisting of ozone layer protection from sun. No, this we can't do. Let's see if you have. This you can do. This will be your homework. This is going to be your homework, guys. Right? The frequency of green light is this. Wave number is what? Right? So C is equals to mu lambda you will use here. Frequency is given this, you know. First you will calculate lambda, and wave number is 1 by lambda. From that you will answer this question. Okay. So let's see if you will be able to answer this question or not. Let's see that. Right, I'll watch for your comments in the comment section before the next class. I want you guys to write it down in the comment section, your homework. And guys, this is our official Telegram channel which you can go, and because all the live sessions are there on the Telegram channel only, and you need to definitely do your homework, because otherwise what will happen, ma'am's heart will definitely break. I don't know what else will happen, and you will lose these DPPs, right, that I'm giving you, right? I'm gonna then take away all the DPPs, right? This is the DPP of some basic concepts of chemistry. You can see this here, and do this today only, or maybe maximum tomorrow morning, right? Complete this DPP of some basic concepts of chemistry. And guys, here we also have pro batch for all the JEE 2027 aspirants and 6 aspirants as well, where it's not like only you can see me, right? Even I can watch that what you are doing, are you even studying or not. There will be a proper dedicated mentor that will be given to you, so that we can actually see, because we know that some students are very distracted. They start chit-chatting in the chat box, right? To avoid that thing, we have this pro batch for you, where doubt 24/7 doubt will be there, live classes will be generated, right? And in the live classes, it's not like we can't see you. We'll be able to see you, will be able to, your cameras will be on, your mics will be on, right? So it will give you all in all an offline experience, right? So that is our Vedantu Pro batches. You can see on 2-year course, 20%, 20,000 off is going on. On 1-year course, 10,000 off is going on. You can click on any of it. Let's say you are JEE 2027 aspirant, you can go through this. This is our 2-year course for 25 to 27, right? And for the droppers here, right, if you're looking for like a good batch which is online at a like minimal price, that is our Sigma JEE batch, which is at 4,999, right, the total cost. So in this batch, no doubt that your cameras will not be on, but if you are dedicated enough that you are like, ma'am, I am a student. If you give me live classes, doubt solving, mock test after every 15 days, test series, quick revision cards, all these things are provided to me, then ma'am, I am a dedicated student, then I will definitely attend the classes. I'll solve the DPPs. I'll attend the classes on daily basis. I'll be there in the mock test. Then this batch is for you, which is at 4,999. Okay? Yes. Okay then students, bye bye, take care, see you all in the next class. And I want you guys to comment down how you like this session. Do you want me to take more sessions like this? And because your ma'am also needs little bit of appreciation, we also need motivation. So our appreciation is your feedback, that is our appreciation, and your homework, that is also, that makes me happy that you are solving DPPs and homework, right? Okay. Okay then students, bye bye, take care, see you all in the next class, bye bye.